Hello everyone, welcome to my channel. So today we will learn about Fermi level, and it is one of the most important topic when we study about semiconductor. It actually shows the concentration or density of charge carriers at any temperature. For n-type semiconductor, Fermi level, you can see the level of Fermi level, it will be closer to conduction band, and for p-type semiconductor it is closer to valence band, and for intrinsic semiconductor it is at the center. And one particular definition, which is, you can say, at 0 Kelvin, only at 0 Kelvin it applies, and it says that it is the highest energy level occupied by electrons at 0 Kelvin, which eventually means that all the levels below Fermi level are filled by electrons, and all the levels above Fermi level, all the energy levels are actually empty, but it is only defined at 0 Kelvin. Okay, now there are three cases, and we will see what happens here. So as you can see that first figure is of intrinsic, and at intrinsic EFI is at the center, all the levels are filled, EV in energy in the valence band, and conduction band is empty. Okay, now what happens at n-type semiconductor? We know that because there is a donor level, because of donor impurity Nd, there will be some additional electrons, n is greater than p, and EFN is drawn between EC and ED, between them, and it is actually midway. Okay, but if you increase the doping, suppose Fermi level, what happens to the Fermi level then if you increase the doping here? So when it increases, it will start, first EFN will start touching the conduction band, and then it can also enter the conduction band. EFN can also enter the conduction band. So that will happen. That is for degenerate case of doping. Similar things will happen here. P-type semiconductor, what will happen? You can now see here that the EFP lies between EA and EV at 0 Kelvin. But what will happen if you increase the doping? Then you can see that at the first it will enter inside the EV. This is actually a short trick to remember what is happening there, and it is not for any semiconductor. This is not for n-type, this is not for p-type, this is not for intrinsic. This is just a trick to learn. So if you increase n or nd at low temperature, first of all what will happen, EFN will start to move upwards towards the conduction band. But at very high temperature, what will happen? It will not go inside the conduction band. Eventually it will start moving towards the intrinsic Fermi level. Why? Because the band to band transition overcomes the impurity ionization, and there will be thermally generated carriers which are more in number, and therefore it will behave as intrinsic. Okay, so now n is not more greater than p. Similar thing happen here for EFP. What will be happen if we at low temperature? First of all, it will move towards the EFP will move towards the valence band. Then it will at high temperature it will move towards the intrinsic Fermi level, and the reason is same, band to band transition will overcome the impurity ionization, and that is why extrinsic semiconductor, p-type extrinsic semiconductor, will behave as an intrinsic semiconductor. So that is the basic reasoning of Fermi level. And if you like this video, please like, share and subscribe my channel. Thank you.